Well, thank you all very much for coming, and in particular, thanks to the Frank Jackson Foundation for making these lectures possible, of course. And I'd like to talk to you about the question we have behind us, but I would like to start by just thinking about how we make advances in science and questions in general. I mean, in science, sometimes in science, you advance by stumbling onto something that suggests a new question, like Penzias and Wilson scrubbing the bird dung out of their radio telescope and discovering the origin of the universe. Sometimes you make advances by answering a question that's been posed for a long time, like, for example, the team at CERN establishing the existence and mass of the Higgs boson. And sometimes you make progress by asking a different question. And this was the case with net zero. A small group of us in the late 2000s realized we were in a bit of an intellectual cul-de-sac with the question we were posing ourselves at that time, and started to ask a different question, still fundamentally oriented on how we limit global warming. And that's the origin of the finding that we need net zero carbon dioxide emissions to halt the rise in global average temperature. I mean, explaining why we had to ask a different question is something I'm going to have to explain over the next 3 lectures. So, of course, you're all coming to all of them, I hope. And by the way, today the visual aids are rather static, but they get more dynamic as we go along, and we actually construct a climate model, a pre-computer climate model based on connected pipes and fluids and things, which of course introduces the possibility of it all going wrong, which makes it much more entertaining. So I do hope you will be coming to those following lectures, because in them I will explain to you why we had to change the question we're asking. But for this lecture, I'm going to do quite a lot of just asking you to take my word for it on the science, although I always feel strongly that you should never take a scientist's word for it. It's the part of our job as scientists is always explaining everything. But so we realized, as I say, in the late 2000s, that we needed to change the nature of the question we were asking scientifically about how to stop global warming. Up until then, just so I'm not leaving you hanging, up until then, it'd be all about what level of greenhouse gas concentrations in the atmosphere we should be aiming for. So some of you may remember 350.org was actually a whole NGO devoted to aiming for 350 parts per million in the atmosphere. And the big debate was, should we be going for 350, 450, or 550 parts per million? If you remember back in the 2000s, that was the argument. And we found we couldn't really resolve it. And for reasons I'll explain in future lectures, we probably never were going to be able to. So instead, we had to ask ourselves a different question, which is, how do we limit global warming by just stopping putting carbon dioxide into the atmosphere altogether? So we, the scientific community, did change the question we were asking in recognition that we weren't getting very far with asking the old question. Unfortunately, the policy community still seems to be asking the questions that it was asking before 2009. And that, I will argue, is why we're making so little progress on climate change. That until we start asking different questions about how we stop global warming, we're not going to get there. But before I get into that, I'd like to make a couple of introductions. So I'd like to introduce you to Art. Not his real name. I can't remember his real name, to be honest with you. But Art is somebody I met back in 2007, late 2007, when I was giving the first time I gave a lecture outside of academia on the topic of net zero. And the lecture, before somebody goes and researches it and does an expose, my expenses were covered by a major international oil company, and I was talking to the Libyan National Oil Corporation in Tripoli. And I was staying in a guest house belonging to the oil company. And while I was there, the guest house was entirely empty, so I thought, but when I came down for breakfast, I met a friendly Dutch engineer. and who I'm calling Art for the sake of, inventing a name, I'm afraid. And we got chatting, and I asked him what he was up to and why he was there, and he explained to me very quickly. He obviously knew the sensitivities, so he said, well, normally we use Libyan engineers, but where he was heading for, it was a drilling site somewhere in Libya where the well was so deep and the conditions on the surface were so hot that the drill fluid, the fluid they used to lubricate the drill was above boiling point when it came back out of the well. So the whole situation was so dangerous, because it would literally explode if you depressurized it fast enough or something, that they only allowed their sort of specialized international engineers to do it. This was because the company took health and safety very seriously. And then he asked, so what do you do? So I was like, well, I'm a climate scientist, and I'm here to give a lecture on global warming. And I sort of fully expected him to I didn't know what to expect. Immediately, he said, oh yeah, that's a very important issue. And he started to tell me how back home in the Netherlands, he and his partner had just fitted solar water heater panels. This was the days before PV was everywhere. And he'd clubbed together with his neighbors to fit them on all their houses. And he'd given up using a car last year. He was a very enthusiastic environmentalist. And then he headed off into the desert, and I never met him again. But I often think about that conversation because it's that separation of the two halves of Art's life that I think are a big part of the problem we face in dealing with climate change. We'll come back to it. And then 12 years later, after we published the net zero papers, we had the IPCC fifth assessment report, we had the Paris Agreement, we had the IPCC's 1.5 degrees report, which established we needed to get to net zero by 2050 or so if we wanted to limit warming to 1.5 degrees. I had another meeting, this time with Zoe. Again, I can't remember her actual name. I'm not very good at names. But Art and Zoe, I sort of just made them up. But this was during the school strikes of 2019. And you can see where I was there with my I'm a Climate Scientist, Ask Me a Question t-shirt on. And I was talking to Zoe, this is just outside Parliament, and she was very, very anxious about climate change. Although she looks very cheerful here, she's smiling for the camera, but she had a lot of questions. She'd basically been told for 19 years of her life, or at least the part of the 19 years she could, she was 19, that it was her fault. And she was worrying, all the questions she had for me were about, she was already vegetarian, should she go vegan? She was going to take a gap year. Should she travel? And if so, how should she travel? And all of it was about her fault. And when I said to her, have you she was, yes, she didn't like what the government was doing, but she wasn't quite clear what she wanted them to do. And when I asked her about fossil fuel companies and the companies what their responsibilities were, she just said, well, they're the problem. And hadn't really thought about their position in this at all. So this lecture, and this whole series of lectures, is about connecting Art and Zoe. Just to remind you where we were in 2007. So when I gave that lecture in Tripoli, this was the model of climate policy that people had in their heads. This wasn't very long ago. This is 15 years ago or so. This is the way we thought the problem would be addressed or should be addressed. And this was something, so the idea was we would contract, and contraction and convergence was the buzz phrase. And the idea was that some countries in the world, some people in the world, consumed much more, or generated much more carbon dioxide per head of population than others. So those in rich countries would reduce their emissions per head. Those in poor countries would increase theirs. They'd meet in the middle at some point in the future, and we'd, live happily ever after in a sustainable future. And that's the sort of scenario here, which you can see, this was a quote from Manmohan Singh, the Indian Prime Minister, in 2008, that this was the model of climate policy that people had, even as late as 2008. And what's interesting is that this was a very politically comfortable model, because it meant that poor countries could increase their emissions. Yes, rich countries who had the higher historical responsibility would have to reduce theirs. But there was a future for everybody in that, and there was a future for everybody using fossil fuels in that scenario. The problem with it is that, and you can see that the picture is that we end up in 2100 with emissions sort of, roughly half what they were in 1990 was the sort of scenario they had. The problem, of course, which came out in 2009 in a whole series of papers published that year, was that actually there is no long-term sustainable rate of emission of carbon dioxide. That the total warming you get, the temperature you end up at, is determined by the total amount of carbon dioxide you release into the atmosphere, and therefore, if you want to stop the warming, you have to reduce carbon dioxide emissions to net zero. Interestingly, looking back at the original papers, we didn't actually use the phrase net zero. It didn't occur to us as physicists to say net zero, because for a physicist, the word net is redundant. It's just zero. 1 plus minus 1 is 0. You don't need to say it's net zero. So net zero came along a bit later. But let me explain this and illustrate this point with an illustration. We don't, I think, see enough fossil fuel. So here's some fossil fuel. In case some of you may recognize this stuff, but a lot of people haven't even seen it. I bet the younger people in the audience probably haven't seen. This is anthracite coal. And each one of these little lumps of coal represents 500 billion tons of fossil carbon. So at the time we published the net zero papers in the late 2000s, sorry, I'm supposed to be this side of the table, I beg your pardon. Apologies to those online. At the time we published the net zero papers in the second half of the 2000s, we just collectively burned through 500 billion tons of carbon, one of these little lumps of coal. And what we showed in those papers was that each of these lumps, if burned, and all the carbon dioxide it generates released into the atmosphere, causes 1 degree of global warming. So we just burned through the first 500 billion tons. That took us 250 years. 15 years later, we are 1/3 of the way through the second 500 billion tons. And if we burn it all, that'll take and release all that carbon dioxide to the atmosphere, crucially, that will take us to 2 degrees. Meanwhile, over that 15-year period, we've decided we don't want to go to 2 degrees, we want to limit the warming to 1.5 degrees. So we've only got half. If you think we've used 1/3, there's not much left, and we're sort of closing it off fairly rapidly at the moment. So that realization, for me, completely changed my view of the climate challenge, because it became clear to me that we were going to generate more carbon dioxide by burning fossil fuels than we could afford to dump in the atmosphere. That seemed to me to be obvious. Interestingly, that remains a controversial thing to say. But there's a strong, let me say, rather than saying it with certainty, I would simply say there's a very strong chance we will generate more carbon dioxide by burning fossil fuels than we can afford to dump in the atmosphere. And as soon as you realize that, it fundamentally changes the nature of the climate policy question we need to address. Because from being a challenge of how do we burn this second lump slower, it becomes a waste disposal problem. If the question becomes, how do we get rid of that extra carbon dioxide that we can't afford to dump in the atmosphere, that we're going to generate, but we can't put in the atmosphere? And that's the framing of climate policy that I've been struggling with ever since, struggling to get across to people that we have to focus on this aspect of the problem that is dealing with this CO2 waste that we can't afford just to fly tip into the atmosphere as we're doing it at the moment. That said, of course, part of waste disposal, part of waste management, is minimizing the amount of waste you generate, of course. So absolutely, we do need to burn this second lump slower. It's nuts that we're burning it faster than ever right now. But we also have to acknowledge that we need a plan for dealing with the carbon dioxide generated by whatever fossil fuels we burn in excess of the limit that we can afford to dump in the atmosphere. And that sort of fundamentally changes the way you have to think about the climate problem. So just to go back to this, climate policy before net zero question, I mean, that was the graph that Aubrey Meyer put up in 1990 when he first sort of envisaged this contraction and convergence scenario. That's what's actually happened to emissions since 1990. That's what they thought was needed to stop climate change, and of course what is actually needed is to reduce emissions all the way down to zero. And I'll explain why in the next 3 lectures. So if you want to know why it has to go to zero as a matter of physics, that's the topic of the lectures coming up. The next question, of course, is okay, we need to stop dumping carbon dioxide into the atmosphere to stop climate change. And the next question, of course, is, well, how long have we got to do that? And again, it's easy to get lost in the complexity of scenarios of future climate and the complexities of climate modeling, when actually it's really very simple. And I spend a lot of my life as a physicist trying to make things as simple as possible. That's kind of what we do as physicists. We look for sort of simple ways of explaining things. And the simplest way of conveying why we haven't got very much time left is just to think of it in terms of a braking time problem. If you think back to your driving theory test, if you've got 3 seconds before you get to the junction, if you've got 1.5 seconds before you get to the junction, and you hit the brakes now, you've got 3 seconds to stop. And then you'll stop at the junction. Yeah? If it's not obvious why it's 3 seconds, think about it. One of your neighbors is probably nodding as if they understand why it's 3 seconds, not 1.5, because you're slowing down. Okay, then talk to that neighbor afterwards if it's not obvious why. Okay, so that's the driving test example that everybody knows, or at least knew for the short duration in which they had to do the driving theory test. On current trends, we will reach 1.5, if it's by exactly the same logic, if it's 15 years before we reach 1.5 degrees, then we've got 30 years to stop the warming. It's exactly the same maths. And at the moment, we will reach 1.5 degrees before 2035, so that's why we need to stop the warming around mid-century if we want to stop if we want to limit warming to around 1.5 degrees. So it's not a matter of complicated modeling. There's much we can criticize in climate models, but you don't need them to understand this. It's a simple matter of geometry. We're at 1.2 degrees right now. We're warming at 0.2 degrees per decade. In order to limit warming to 1.5 degrees, we've got about 30 years to stop it. Well, less than 30 years now. So, it's clear to me, and I hope it's reasonably clear to you, that we have to stop fossil fuels from causing global warming. And this image behind me is an illustration of quite how hard that could be. A lot of my colleagues, I'm in a geography department, but we're working with social scientists and economists. They're very fond of saying, well, the one thing we really need to do to address climate change is introduce a carbon price. A carbon price is what we need. And I like to show them this figure because it's a village in Greece where they discovered the village was built on lignite, a very high carbon form of brown coal. And as you can see, they dug out the ground underneath their houses, leaving only the church standing in order to get at the lignite. So if anybody ever tells you the solution to climate change is to introduce a carbon price, point out that only a carbon price higher than the threat of eternal damnation would be enough to stop people using fossil fuels. So we need to stop fossil fuels from causing global warming before the world stops using fossil fuels. Talking of carbon prices, remember back in 2018 when Macron introduced a carbon price of 12 euros a tonne? We'll be talking about much higher prices as we go on through this lecture. It almost brought down his government with the Yellow Vest movement. So we can't, so fixing this problem by telling people not to use fossil fuels isn't working. And what really worries me at the moment in the UK is the progressive climate, those who care about climate seem to think that what we need to do is just try harder to tell people not to use fossil fuels. And we've already got a building reaction to that with, I understand, the likes of Nigel Farage seeing this as an opportunity to find the next big Brexit cause, fighting back against the net zero agenda, telling them not to use fossil fuels. So, although I've got the sign here is in French, I could well imagine similar marches in Britain in the latter part of this decade when, in theory, we're banning internal combustion engine sales and requiring everybody to drive electric cars. And the middle classes are all fine because they've got driveways to plug their cars into, and everybody else is spending 20 minutes every night wandering around looking for a charging post. That's exactly the kind of scenario that would be jam for Nigel Farage, I've no doubt. So how do we stop fossil fuels from causing global warming before the world stops using fossil fuels? Well, one solution which rather blindsided me, to be honest, when it suddenly got everywhere about 2 or 3 years ago, is the idea, we can solve the problem with nature. Nature will be the solution. We can plant trees, and the trees will absorb the carbon that we're generating by burning fossil fuels, and this is how we will solve the climate problem. There was even a headline in a scientific journal, trees, the best solution to climate change to date was, I think, the line they came out with. Lots of people obviously liked this because people like trees, people like all the benefits of planting forests and so on. There's a lot that can be got out of this. Some fossil fuel companies even like to encourage us that we can drive carbon neutral by planting and restoring forests, by protecting and restoring forests. The problem, when you think about this as a physicist, thinking about the planet as a whole, is can we rely on the biosphere as a place to put the carbon that we generate from burning fossil fuels? And this, sadly, is a rainforest in Brazil where large amounts of Norwegian money had been spent protecting that rainforest for carbon credits. And it's great that they did protect the rainforest, but then sadly there was a change of government in Brazil, and this is what happened to it. Carbon in the biosphere, it's very important to protect it, but relying on it as a carbon dump, as a place where we can just dump the carbon dioxide we generate from burning fossil fuels, is not a viable solution. In fact, we published a paper last year which looked specifically at this, taking the most optimistic estimates of what we could achieve through nature-based solutions to capturing carbon, and we found they could shave perhaps 1/10 of a degree off global temperatures by mid-century, perhaps 2 or 3/10 of a degree by the end of the century, for the simple reason that trees take time to grow. And meanwhile, fossil fuel emissions are driving up global temperatures by 2/10 of a degree per decade. So yes, nature-based solutions can help, but to suggest they're the solution and that we can neutralize our impact on the climate by appealing to nature, I think is probably the most misleading aspect of net zero discussions at the moment. And it's understandable that, in fact, many young people are getting quite angry about net zero because they see it as just an excuse for companies to say, yeah, we're net zero, we bought some forests somewhere, we've got this whole thing under control, meanwhile we're just carrying on with business as usual. And it's understandable why people are getting angry about this. So, do we have to do what these demonstrators are arguing and just ban fossil fuels entirely? Keep it in the ground was the big slogan a few years ago, and now we have a movement for a fossil fuel non-proliferation treaty where people can sign up, and many cities are now signing up to this, and lots of churches are signing up to say we're going to ban new extraction of fossil fuels entirely. And one of the big results of COP26, the big meeting in Glasgow last year, was various governments, including our own, agreeing that we would no longer fund new fossil fuel projects in development through development finance. So, for example, we've been firmly saying to various countries in Africa that we won't lend them money to develop their fossil fuel reserves. Now, we're busy inviting investors to develop fossil fuel extraction in the North Sea while turning around to Mozambique and saying, no, you should leave your gas in the ground. And understandably, a lot of African countries are not happy about this. And it's completely understandable why, because the whole notion of keeping it in the ground, you've got to ask yourself, whose ground are you keeping it in? This is a map from geoexpro.com, which I'm sure is not an environmentalist site, but it shows you wells to watch in 2022. These are the sort of big prospective oil and gas finds at the moment, where they think there's a lot of fossil fuels there. Just look at where they are and ask yourself where the demonstrators are who are saying keep it in the ground. And you can see why we've got a problem here. We in Britain who've been busily burning our fossil fuels for 250 years, suddenly turning around to Ghana, to Mozambique, and saying, no, we want you to leave them alone. So we need a different take. We need a different approach. And let's just step back and think about the problem as a whole. So this is where we are. We're extracting carbon. The thickness of the arrows shows you the flux of carbon dioxide moving from one sphere to another. You can think of carbon in the climate system as residing in three spheres that are directly affected by human activity. The atmosphere, the biosphere, and the geosphere. So the biosphere is mostly plants and biologically active soils. The geosphere is rocks, sediments, and of course, fossil fuels. So at the moment, we are extracting carbon from the geosphere at a colossal rate, dumping it in the atmosphere. We're also extracting carbon from the biosphere by burning down forests. We are recovering some carbon into the biosphere, but overall there's a net flux out of the biosphere. So the amount of carbon in the geosphere is going down, the amount of carbon in the biosphere is going down, and the amount of carbon in the atmosphere is going up very rapidly. This is what most people think of as net zero. At least this is the way net zero is envisaged in most net zero commitments today, which means we balance, we sort of achieve a delicate balance. By the way, this is the way net zero is defined in the UK government's thinking. In case you think, I'm not just sort of talking about companies here, this is also in our government's thinking. We achieve a sort of delicate balance between carbon into the atmosphere and carbon coming out of the atmosphere. But you can see we're still taking carbon out of the geosphere, even though we've introduced some return carbon, some capture from the biosphere. This would be processes like burning biomass, capturing the carbon dioxide and re-injecting it underground, something that we're proposing to do in Yorkshire. We can talk about that later if you're interested. There was an interesting program about it on Panorama last week. This arrow here is where it's more newer technologies for actually capturing carbon dioxide straight out of the atmosphere and putting it back in the geosphere. But we still have more carbon coming out of the geosphere than going back into it, and that carbon's ending up in the biosphere. So although people think of this as a net zero, and yes, it's a sort of balance in the atmosphere, it should be fairly obvious to you that this is not a sustainable situation. You can't turn rocks into trees forever. So this is at best a temporary solution. If we want durable net zero, we need this situation where carbon flows into and out of each of these three spheres are balanced. And crucially, we have geological net zero, which means we're putting back into the ground the same amount of carbon that we're taking out of the ground. Until we get to that state, we're not going to stabilize the climate system. So achieving geological net zero is fundamental to solving climate change. And it comes down to how we stop fossil fuels from causing global warming. This graph behind me shows you a generic average scenario where we do meet the Paris goal of limiting warming to 1.5 degrees. It shows you in blue emissions to the atmosphere, the dark blue line, which start from energy and industry. There's land use change emissions as well. That's a separate talk. We need to bring those down to zero, emissions to the atmosphere. But what, and you've seen this graph, I'm sure, many times, needs to get to net zero sometime in the 2050s or so. But what you're often not shown is that in these scenarios, we don't actually reduce the amount of carbon dioxide we produce in energy and industry by nearly to zero. It goes down by about sort of 2/3 to 3/4 or so. So we achieve net zero, first of all, by burning less carbon, so we generate less carbon dioxide. It's got to come down a long way from where it is now. But at the same time, we also ramp up the amount we store back into the ground. And that is the only way we do this at the moment on any scale, there are various other ideas out there, is by capturing carbon dioxide, purifying it, compressing it until it's a liquid, when it has properties very similar to water or for that matter, oil and gas underground, and re-injecting it back into the rock. You can do this. Indeed, the fossil fuel industry has been doing it for decades. And if you inject it into the right rock formations, it stays there. But that's the only way at the moment we are putting CO2 back underground. And at the moment, we re-inject 40 million tons of carbon dioxide into the geosphere in this way. 40 million tons sounds like a lot. But in perspective, that's 1,000th of the 40 billion tons of carbon dioxide we generate every year from burning fossil fuels. So of every ton of carbon dioxide, which if it was liquid would be roughly a cubic meter, obviously if it's a gas it's much bigger than that, but a ton of carbon dioxide as a liquid is roughly a cubic meter, we safely dispose of 1 litre, 1 kilogram. The rest we just dump in the atmosphere. So if we want to stop fossil fuels from causing global warming, it's very simple. We need to reduce the amount of carbon dioxide we're producing and increase the amount we're storing until they balance. That's it. That's all there is to it, as it were. So right now, we're at 0.1%, 1,000th, and we need to get that stored fraction, the amount of carbon we stick back into the Earth's crust, to 100% to stop climate change. What will this consist of? Where will we get this carbon dioxide from? Well, to start with, there's a lot of carbon dioxide being generated around, pure carbon dioxide comes out of refineries, which would be relatively easy to trap and re-inject into the Earth's crust. But quite rapidly, as we progress through the next 30 years or so, we're going to run out of those convenient sources of carbon dioxide. And by the time you get to 2050, probably most of the applications that we're still using fossil fuels for will be things where you can't really capture the carbon dioxide where it's generated. You can't put a big plastic bag on the back of a jet engine and capture all the carbon dioxide coming out of it. Well, apart from anything else, it wouldn't work as a jet engine anymore, would it? So for those kind of, and aviation will still be using fossil fuels, I would confidently predict, in 2050. So that's one example of an activity which we won't be able to capture carbon dioxide where it's generated, and we'll have no option but to capture it back out of the atmosphere, to recapture carbon dioxide from the atmosphere and stick it back underground. So in these scenarios, that's what happens. We eventually achieve net zero by recapturing carbon dioxide back out of the atmosphere and sticking it back underground to balance the carbon dioxide that's still generated by any further use of fossil fuels. you should ask yourself immediately, really? Is that how it can work? I mean, can we really suck carbon dioxide out of thin air? I mean, there are companies already out there saying we can do this, but you should always be slightly suspicious. This is, of course, an artist's impression of a plant. Although it is a plant that is being built, and we'll come back to this plant in a minute, because I think it is a very important, it's an important new data point we've got at the moment. But this is a collaboration between a company called Carbon Engineering and indeed Oxy, a large oil and gas company, to build a plant that will suck air in, filter out the carbon dioxide from the air, compress the carbon dioxide until it's a liquid, and then re-inject it back into the Earth's crust. They will, as in an interesting twist, be using that carbon dioxide to flush out oil from the Permian Basin, because it's a very useful fluid for flushing out oil in the Permian Basin. So the exact balance of fossil in this project is debatable and debated, but the crucial point is they are putting carbon dioxide away back into the Earth's crust, and it stays there. That's the important point about that project. And the other point about the project is that it's real. They're already doing this. They've had a pilot plant running since 2015 in British Columbia, and so that sort of purple thing in the middle has been busily capturing carbon dioxide from the atmosphere and showing that this whole thing works, and they've costed it, and so they know what it's, and hence they're in a position to actually go ahead with a full-scale investment. A little bit closer to home, slightly less beautiful background, but here's another pilot direct air capture plant in North Lincolnshire, where Origin Power are using a process I can talk to you afterwards about if you want, about where they're generating essentially pure carbon dioxide stream, which you could then re-inject underground, and lime, which you use to make cement, and therefore you could use the combination of these two to actually trap carbon dioxide back out of the atmosphere. Interestingly, Origin, although Carbon Engineering have got a license from the US government to start putting their CO2 back underground, Origin can't get a license to get rid of their CO2. So they're just venting it back into the atmosphere. But that's the problem we face. So, sorry, now, what does this cost? This sounds like a lot of work to be done, and until recently, it's been quite difficult. Estimates for what it would cost to actually get rid of CO2 on an industrial scale have been all over the place, from $1,000 per ton, $100 per ton. Finally, because of these projects, we're actually starting to see what it really costs. Because that Carbon Engineering Oxy project that's going ahead in Texas is going ahead on the back of a subsidy from the US government. I'm not a big fan of subsidies, but it's quite helpful in this particular case just to work out what it's costing, of roughly $250 per ton of CO2. So although Oxy and Carbon Engineering claim to be very virtuous global citizens, and they're doing this as a loss leader, and it's all, but they're probably not losing that much money on it at $250 a ton. So that's giving us a data point. We know roughly what it costs, or roughly what the industry thinks it would cost to recover carbon dioxide from the atmosphere and stick it back underground, which of course is what we need to do to stop fossil fuels from causing global warming. So what does that mean? And this is where I want to get you a little bit riled up. What does $250 per ton of CO2, that's the cost of disposing of it, what does it mean in the context of what we spend on fossil fuels? Well, just unit conversions here. It's roughly $100 on a barrel of oil, which sounds like a lot, but, the price of oil has fluctuated by more than that over the past 30, 40 years, which tells you that quite frequently over the past 40 years, the aggregate rents, that's the combination of monies paid to governments and profits made by the extractors, have been well in excess of the cost of disposing of the carbon dioxide generated by that oil. So, or another way of putting it is, also the world economy, although it's wobbled a bit when the price of oil goes up to $100 a barrel or higher, it doesn't collapse. So we definitely can afford, particularly if we have time to adjust to it, those higher prices of oil. So it's clear that we could afford to get rid of the CO2 generated by the oil we use. And it's even more obvious when you look at it in the context of petrol prices. This is petrol prices in the UK since 2000. You can see between 2004 and 2019, petrol prices went up by more than the cost of fully disposing of all the carbon dioxide that petrol generated. That's for somebody, either the company selling you the petrol or somebody else, to literally recapture that carbon dioxide out of the atmosphere and stick it back under the North Sea. People object when I point this out, because they say, well, if you say that, then people won't stop driving. Well, if we all had to pay for the cost of carbon dioxide disposal, we'd probably drive a lot less, and we'd probably drive electric cars. So it doesn't necessarily follow, but the key point is here, we've had a solution to climate change all this time. We're just not choosing to talk about it. It's even more striking if you look at natural gas. A $250 per ton cost of disposing of CO2 is 4p per kilowatt hour on natural gas, which, if you think about what we're spending on natural gas at the moment, isn't a lot of money. So let me give you a thought to think about. $250 per ton disposal cost for carbon dioxide, which we're already seeing some evidence is realistic. It's probably an overestimate of what it would actually cost if the industry had to do it at scale, translates into the royalties and profits, and it's important, it's not just profits made by private companies, but a lot of it is royalties going to national exchequers. The combined royalties and profits on what we pay for gas today is enough to pay to recapture every single molecule that gas of CO2 that gas generates and to stop it causing global warming and stick that CO2 back under the North Sea twice over. And nobody's talking about this. So, I want to think about how, in the course of these lectures, how we can reconcile art and Zoe. The way we think about the climate issue is this titanic battle between people like Zoe and people like art. And the problem with that, if you frame it that way, is somebody's got to lose. And I don't want either of these people to lose. They were both really nice people. They both care about the planet. Art probably, maybe Art is Zoe's father. That would be fitting, wouldn't it? Okay, but you know, and it's not working either. Framing it as this battle between, you know, irresistible forces and immovable objects. So we need to look for climate solutions that don't pit the fossil fuel industry against the rest of the world, because the fossil fuel industry remains 80% of our energy supply, hasn't budged much in the past 30 years, despite all the angst about climate change, and it has the resources, as I have stressed to you, to solve the problem. Some chief executives have even admitted they're not quite sure what to do with their money at the moment. Well, here's a thought. They could solve climate change, couldn't they? So, to sum up, why net zero? Well, we need to stop fossil fuels from causing global warming. And to do that, we need geological net zero. We need to balance carbon coming out of the geosphere with carbon being put back in the geosphere. And we need to do that before we stop using fossil fuels. Because the only way we can achieve, there's only two ways to achieve geological net zero. One is to ban fossil fuels entirely, and that's all very well saying we'll ban them for ourselves in Britain, but you know, what right do we in Britain have to say we're going to ban you from using your fossil fuels in Mozambique? So that's not feasible. So we have to work out how to decarbonize fossil fuels by safely and permanently disposing of the carbon dioxide they generate. And over the course of these Gresham lectures, I'll both explain to you why we have to do that, how fast we have to do it because of the emerging impacts of climate change that we'll be talking about next year, and in the third year, I hope, how we're going to do it. And by that time, maybe more people will be listening to me and the situation will be changing, and we'll be getting more mileage out of this approach to solving climate change. But in the meantime, I hope I've given you enough to think about today that you'll go out and spread the word and start to think more open-mindedly about how we solve the climate problem. Thank you.
Do you indeed worry that your concept of net zero is actually a dangerous concept in the wrong hands?
Well, I can imagine who the wrong hands are that John is thinking about. And it is fair enough that the fossil fuel industry hasn't exactly covered itself with glory over the past 30 years on this issue. Expecting them to solve the problem does sound like, for many people, counterintuitive, and understandably so. I'm absolutely not suggesting that we trust the fossil fuel industry to solve the problem. Absolutely, back to the old Cold War adage, trust but verify. We need a strong government, strong regulation to make sure rules are applied and rules are followed if we're actually going to implement this. The danger, of course, is if the industry uses its lobbying power to sort of persuade the government to duck and weave and get around it, then that is indeed dangerous. But the alternative to insisting the industry dispose of carbon dioxide by putting it back underground is dumping carbon dioxide in the atmosphere. And that, I'm confident, is more dangerous than putting it underground. So it's a balance of risk. And the way we're going at the moment, it's all just going in the atmosphere.
Thank you very much. Mark Falcon. Thank you for a fantastic lecture. Now, I'm both a physicist and an economist. So isn't
what a conflict.
Well, I'd say no. What economists advocate is not just a carbon price, but a carbon tax, i.e., on the polluter pays principle, that those who cause carbon emissions in whatever form pay that tax, and those who sequester it receive that tax as a negative tax. So surely isn't that exactly what you're advocating?
With a twist, in that I would advocate doing it through regulation rather than a tax, because I worry that... imagine if the present government had a multi-billion-pound-a-year income from fossil fuel taxes that was meant to be spending on carbon dioxide disposal. Imagine briefly what they would probably do with it instead, bearing in mind the impact of carbon dioxide disposal would not be visible before the next election. Okay, that's why I'm terrified of the idea of the government doing this. So I firmly believe the way to do this is by requiring the industry to do it through regulation, not through the mechanism of taxing them and then spending the money on getting rid of CO2. So it's a sort of political argument. I know economically it's exactly the same thing. But once politicians get their grubby paws on money, heaven knows what happens to it.
It's such a cynic, Myles. Now I'm going to take...
Well, we are in the world we're in.
I'm going to take another question from our online audience. Again, you did touch on this in the lecture, but I think it's worth pursuing a bit more. What do you think about the government's announcement last week that they're offering new licenses for oil and gas exploration in the North Sea?
It would have been a golden opportunity to make those licenses conditional on getting rid of some of the CO2 that will be generated by that additional oil and gas. But that was asking too much. But why not? A 10% storage requirement by 2030 would add 5p to the cost of a litre of petrol. It would be invisible in the fluctuations in prices that will happen between now and then. And yet, no politician will touch this with a barge pole. I don't understand why not. Because it's a way of solving climate change that doesn't involve them setting up lots of complicated incentives and interfering with people's lives.
I wanted to know if your position is that governments can't be trusted to do this, but we have to be alive to the danger of the fossil fuels lobbying for their interests. how do you propose, or what tools do you think are the most powerful for getting us to that regulation that you're advocating for?
Well, in the end, regulation requires government. I'm not anti-government by any manner of means. We need government. We need good government, if only. And the fossil fuel industry is already pretty tightly regulated. It's one of the most regulated industries in the world. Everybody knows what it's doing. So it would actually be relatively straightforward to simply require the industry to do this. And, you know, after the 1.5 degrees report came out in 2018, we were doing lots of talks to various people, and I gave a talk to an annual get-together of young engineers from one of the big oil and gas companies. I was talking about 1.5 degrees, and somebody asked me at the end of the talk, you know, do you think there's any chance of us actually meeting 1.5 degrees? And I just turned the question around and said, well, if you had to decarbonize your product by 2050, if you had to get rid of 1 ton of CO2 for every ton generated by the oil and gas you sold, would you be able to do it? And they just said, well, would the same rules apply to everybody? And I said, yeah, okay, suppose they did. And then of course we would. So the industry is very used to dealing with regulations, to complying with regulations. But they have to know those regulations are coming, and once those regulations are in place, they need to know they're going to stay there so that they can invest against them. So who do I trust here? I mean, I don't think we can afford to trust anybody, but at least this is a way forward where, you know, the government doesn't have to do very much. It just has to introduce a rule and monitor to make sure that rule is complied with, and then the industry is more than capable of complying with the rule. So I think it's, of the various climate futures I can imagine, it seems to be one of the ones that involves trusting people least.
I'm going to ask the question from a member of the online audience, largely because Nadine kicks off her question by saying, thank you so much for the brilliant lecture. It's always a winning start, I think. But. There isn't a but. She asks, do you have concerns that there may be some hidden major surprises in the global carbon cycle that we don't yet understand? Unknowns in the biogeochemistry, ? How well do we know the carbon cycle?
Nadine, please come to my lecture on the carbon cycle, which will be the fourth lecture of this series. And yes, there's a lot we need to worry about in the way the climate's evolving and will evolve in the future. But this is, all, in my view, all the more reason why we need to build a capacity to get rid of carbon dioxide on an industrial scale. Because unless we have that capacity, we can't turn the ship around. We can't, you know, we may well discover in the second half of this century that we actually need to draw carbon dioxide actively back out of the atmosphere. Lots of scenarios involve us doing this. But at the moment, the plan seems to be, we'll just carry on burning fossil fuels until the mid-century, paying fossil fuel companies for their products and burning them, and then we'll use taxpayers' money or something, I don't know whose money, to pay for vast amounts of carbon dioxide removal. So, you know, you're paying private industry to create the problem, and then you're using taxpayers' money to clean it up. I mean, this is something we've done in the past. We do tend to do quite a lot. But if you can avoid it, it's better to avoid it, which is why I would argue that getting the industry today involved in developing the solution is the right way forward.
This is a very general question. How optimistic are you that net zero will be achieved by 2050?
Well, I often think back to that meeting with Art, and Art could do it. He was doing amazing things every day. It was part of his job. But we're not even asking the likes of Art to do it. And so I vacillate between, and it's really frustrating. I know this is possible. If we actually enlisted the power of the fossil fuel industry, the ingenuity of the fossil fuel industry, the resources, the capital, the cash flow, all the stuff they've got to solve the problem, we'd have the problem solved. People love to talk about the takeoff of wind and solar in the US, the exponential growth of wind and solar in the US in the past decade. If you plot on the same axis, in terms of energy delivered, the takeoff of unconventional shale gas, it's like that. It's a super exponential growth to a much bigger target. And what were they doing? They were injecting fluids under pressure into rocks. They know exactly how to do this. And they could do it like that if they were required to do so. If it was a licensing condition of continuing to dig up fossil fuels and sell them, that they had to get rid of CO2, they would just get on with doing it. Of course, fossil fuels will then become more expensive. We won't use nearly as much of them, probably at least 3/4 less. But the remaining fossil fuels we use won't be causing global warming. So we could do it. But what is frustrating is you won't find this approach to addressing the problem being discussed anywhere. And so that's what makes me less optimistic, unless we can change the mindset of people thinking about climate policy, come back to where I was at the beginning, thinking about asking a different question, not from can we produce carbon dioxide a bit slower, but how do we get rid of the carbon dioxide, the excess carbon dioxide that we're going to produce? Until we get people's minds focused on that question, we're not going to stop climate change.
And that's a very good cue for me to thank the Frank Jackson Foundation for all your support for this wonderful professorship and our wonderful new professor. And I'm flooded with questions now from the online audience and the in-person audience, but I think we do have to stop there. But the answer is to come to the next lectures, and I'm sure Myles will answer the questions that you're burning to ask at that point. So, look, thank you so much. That was a wonderful lecture. Really appreciate it, and indeed look forward to the next ones.
Thank you.
Thank you.